So we'll go right into MapReduce. So MapReduce, I'm going to kind of reiterate a lot of things from the curriculum. So if you guys have questions on MapReduce in particular, this is the time to ask it. It's kind of like MapReduce is, in my opinion, kind of like the uncreative way that computer scientists name things. Basically, there's two main steps, which is MapReduce, but there's also other steps in between. So I don't know why computer scientists also only named it MapReduce. It could be like Map Shuffle Reduce or MSR or something. I don't know. I guess whoever made it's just what it is. But anyway, basically it comes describing two different parts, which is mapping and reducing. Okay. And what's really nice is that it's really meant for clusters. This doesn't really make sense if you're trying to do it on like one CPU, one brain, essentially, because it's like you might as well just do it yourself. But if the data are so large that you can't fit it on one CPU, basically one brain, you probably are going to want to do something where you split it up in a distributed system, and MapReduce is one philosophy to do this. So this is directly from the curriculum, and I'll kind of like walk it through a little bit, is that you start off with a data file, or a large amount of data. In this case, it's the zoo file. In this case, you can imagine, I think you can kind of think of this like, you know, there's different animals, right? And each line might have multiple animals in here. Going through, not in any particular order. And your goal is to say, how many animals are there in this list? You know, how many lions are there? How many wolves are there? How many blah, blah, you know, any animal in there. So this way we put it into different parts. So note that this is technically from the curriculum, but I think I added a couple, or I might have moved over the words a little bit, because I think before it was like showing split. So the first step really is like this part right here. All the times you see these arrows are the actual steps. So the first part is what we call split. Basically, we take this data file and we're going to chop it up to put it onto a different CPU. So you imagine 1, 2, 3, 4, 5 CPUs in this case. Oh, they forgot an arrow. So basically, there are like 5 different computers going to do this stuff. So we split it up. Say, okay, in this case, we just split up by line. Say, all right, this is the first line, second line, third line, fourth line, fifth line, right? And it's like, okay, that's our part. Easy peasy, right? Super easy. So now we go, okay, we go to our mapping step. And so the mapping part, basically, it's kind of like, you look at this, you're like, why is it so simple? And all we're basically doing is we're taking this data from this one line and saying, let's make something meaningful of it. And this is basically, we're mapping it to a key and a value. So you can think of every time we do a mapping, we're always getting some key and a value. In this case, we're just like, well, how many animals are there? Well, in this case, we're just going to have what animal it is, and then the number 1, since there's only one animal in that case. But note that this could also be something like, for example, let's say you wanted to count how many, the average number of like length word, like you want to say like how long are words on average or something like that. In this case, lion might be mapped to lion, comma 4, right? Because there's 4 letters in lion. So depending on like what you're trying to achieve, your key and value will be slightly different, right? But in the most part, you can see it's relatively simple here. And you can see each part gets its own separate, you know, key value mapping. Okay, cool. All good? Sound good? All right. So next part is shuffle, which I hate. It shouldn't be called shuffle. It should be called like reorganize. I don't know why it's called shuffle, because shuffle makes it sound like it's random, right? It's not random. It's basically the resource management says, all right, let me take your mapping stuff and make it more ordered, which is like the opposite of shuffle, but whatever. Again, computer scientists, I don't know what they're doing. But you can see here basically is that these different like computers right here will get now different parts. It's like, hey, where's all the giraffes? Hey, where's all the koalas? Where's all the lions? Where's all the tigers? Where's all the wolves? And it passes it over. So you can imagine here is that they're just passing it off to the right place. And this is usually done by a resource management system. You could technically do things like with peer networks, but I think for the most part, resource management tends to be a little bit easier for you to kind of process through and kind of reference, and it basically passes through and figures it out. So it shuffles all this information over to the proper nodes, okay? And then we go to the reduce part. Reduce basically is like the real work. So in this case, basically, it's just gonna add them all together. In this case, there's 3 giraffes. So we go 1, 2, 3, we add them all together. We know it's giraffe 3. Note that in this case, you'll see that that each node here, each computer, CPU, got a different animal. You don't necessarily have to do that for your shuffle step. It could technically be that maybe this one CPU might take koalas and tigers. So that's where the resource management system decides on like what should get passed on, and it knows to reduce them. But this is a lot easier to reduce, even if it's like koala and tiger. It's a lot easier to reduce those 2 things than trying to reduce all of these to begin with, like all together. So that's kind of idea. Also note that if you have a lot of giraffes and it can't fit on one CPU, you can split this up again onto multiple parts. So maybe like, 2 or 3 different, CPUs would actually all contain giraffe. Okay, so again, note that there's kind of like some complexity that you can add into this part. But then once you have reduce, you're like, cool, we got all these parts and we put them all together and basically we get our final list right here. So that's kind of like the idea of this process. Another example of this might be something like, I don't know about you guys, but like, I don't know how many times I really have to count how many animals there are that appear in a list. So one thing you could possibly have are things where there are, example of this might be like a list of sales, for example. I say, okay, like where is like, let's say different like sales branches and you have different stores in different areas. So we have like the store in like, I don't know, in San Francisco, a store in Boulder, Colorado, right? And you have like these different like stores everywhere. And you say, okay, this is the store, this is how much they sold and stuff like that. Or like, let's say this is the store and this is what that item that was sold. And you want to count on how much was sold in that particular store. So you could do the same thing here, but in that case, your mapping item would just be your value would be actually how much was sold, in that transaction at that store, and then combine them later on. So you can kind of see how this might like be modified slightly. So again, it's just more of a philosophy than it is like a specific way of doing it. Okay, does that make sense? Cool. All right. So just kind of breaking down a little bit more. I like this. I found this little diagram, which I like a lot. You can imagine these are all like the mixed up parts. We split up this node 1, node 2, node 3. You can think of those each CPUs. And basically you can see different parts. For example, the mapping basically maps it over. It's like, oh, here's all the reds, here's all the blues, here's all the greens for each one. And then the shuffle part, which again, I hate that's called shuffle, but basically all the reds go here, all the greens go here, all the blue goes here. And reduces, maybe for example, just counting how many occur or does some pre-processing stuff. Maybe it counts how many, what's it called, letters there are, in the word or something like that, and then puts into this output. Okay, cool. Makes sense to everyone? Okay. Any questions at all on like how this works or any clarification needed?
I have one question, but it's kind of going back to before. So when we were talking about like Hadoop and Apache Spark, at the very end, my computer was glitching a little, I'm sorry. But so MapReduce is like present in both Apache and Hadoop, right?
Yeah, because it's going to be much more like it's a philosophy of programming, if that makes sense. So like, for example, I'm about to show you guys some code that does not use Spark, does not use Hadoop. It's using a different package. Basically, it's you could definitely do this yourself, like build up like Python objects and classes to do this. And so I'm going to show you guys a different package that's going to do the same philosophy of MapReduce without using any Spark. So definitely, but Hadoop and Spark, you would be using MapReduce pretty frequently, at least that philosophy.
Okay, and MapReduce is pretty prevalent in the big data world.
That's right.
Okay.
Yeah. So that's why it's important to kind of understand like what each step is really doing.
Okay. Thank you.
No problem. Okay. And I don't think I had any extra information here. I just want to make sure if there's any extra notes that I didn't go over. No? Okay. Split, you assign each task to each worker. Note when I say worker, this is pretty common too. You guys should know this. When someone says worker, they mean like a single brain, kind of like what's that worker's task doing? So each worker is assigned a task, okay? So note that kind of terminology is there. Remember that map is kind of like another name for function. So if you're familiar with like mathematics, a lot of times we'll talk about like mapping from A to B kind of thing, or mapping space A to mapping to space B kind of deal. It takes in one data form and makes it into a new thing. It's always a key value pair. So think tuples, right? Shuffle, more like reorganize. I don't know, forget the name shuffle. If you get confused with shuffle, just say it's reorganize. Like computer scientists don't know how to name things. And then reduce, that's pretty obvious. Basically, it takes everything that was already mapped, it's been reorganized, and now it's just combining it together to make it into smaller sets. Okay. Cool. So I won't do any more. So now we can get into some MapReduce code. All right, so yay. So this is kind of fun, is that I decided not to like show you guys directly Spark because I don't think it's necessarily neat. I think it might kind of like convolute some of the stuff, like understanding what MapReduce is really doing. So I found this great package called MrJob, which looks like MrJob, but you know that it stands for MapReduce job, right? So it's all written in Python. So it's really nice that you can actually check it out, kind of see how it goes through. And we can actually run basically, what's it called? we can run MapReduce kind of like style programming without ever having to do anything outside of Python. So if you want to install it, you can run this, but I got to comment it out. So note that I'm just importing this job part in here. And then I actually have some code written already. So the first thing I want to show you basically is this first data set. So I have some data already called songplays.txt. I actually took this from another repository to kind of do this, so now that you can kind of like find this and see like how they kind of put this together. But basically it's just like a bunch of song plays. So you can imagine like this is a list of songs that are playing like on a Spotify playlist. And what you want to do is saying how many times are these songs actually played. So in this case, you can see some kind of fake songs here, Deep Dreams, Data House Rock, I think there's another one, Broken Networks. So there's a few different kind of songs.
Sorry, Victor, what is it when they put the exclamation mark at the beginning?
Oh, this guy right here?
Yeah.
Yeah, this is actually running, here, I'll show you a little bit. When in Python, I guess not Python, but like in Jupyter Notebooks, you can just use that to run command code. So if you like ls, for example, oops, you can see it runs just like, what's it called? Like as if you're in the command line.
Yeah, okay, cool, thanks.
Yeah, no problem. So that's what you can see here is that I could technically take this out and just run it in command line. But I think since we're used to Jupyter Notebook, I just did put it in here. Okay. Yeah, so anyway, this is just a text file here. If I open up song counts, you can see here's data. So PySpark, data, song plays. You can see it's a text list of all these songs, right? There's only like, I think 3, maybe 4 songs. But like, it doesn't matter what songs, how many songs there are, it can do the same thing. And note that this is a big data file. No, obviously this fits on my computer, so it's not really needed. If you wanted to, for example, to count as how many deep dreams occurred, you could probably just do fine, and it would be just as quick, probably quicker than what I'm about to show you. But the concept's there. So I'll close this guy. Just going back to our code here, we want to basically count out how many times deep dreams occur, how many times Data House Rock occurs, right? So I'm actually going to run this code here, Python, and then songcount.py. So note that this is like kind of like when we wrote object-oriented programming code. It's run in this extra file. That way it's a little bit more concise. And this is going to take in basically the data, this text file. It's going to read this text file and then count out how many parts. So I'm going to show you what that song count looks like, because this will kind of show you a little what's going on. So note that basically this kind of like class. Yeah, an object-oriented programming class, right? Kind of like what we've seen before. So you can see here, I basically create a new class called MrJob, MrCount songs. Note that's importing from MrJob, right? Or sorry, not importing, inheriting from MrJob. And so this automatically gives us a few functions called a mapper and a reducer. That's all we have to define. We're basically going to take, whatever it gives us, and we're going to say, okay, whatever, this is basically if there's a new key, like a key value, we can take that new key. But since basically we're going to have just the line that's going to read in, it's going to be the name of the song. So the song is going to be our new key, and then our value is just going to be the number 1, since it's like, oh, Data House Rock occurred 1 time. So it's going to return this tuple of the song, Data House Rock in this case, comma 1. So this is kind of like our key value part. Does that make sense so far? Okay, now the one part you're probably looking at is like, what the heck is this? Like this yield thing, which you'll probably say like, I haven't seen that before. Like, and this basically, you can think of this as return. So remember like how a function can return things, but yield does something a little bit different, where instead of saying like, return, and then what happens to you return at the end of the function stops, right? Nothing happens anymore, right? So what yield does, yield basically will take, this, will take the information, this self is going to be all the data, and it's going to take one at a time. So if you call this function again, it'll take you the first one, and then you call it again, it's going to take you the second one. So for example, this is called a generator. And we've actually seen generators before. When you do range, if you remember, if you do like a range of 10, oops. Does anyone know what this returns if I just go ahead and print this out? It doesn't return a list, right? You're like, huh, weird, right? And that's because it's actually generating. And what's happening when we do, for example, if I do for I in range of 10, and I say like print I, what's happening is that every time it goes around, it's actually calling range 10 every single time. However, range is basically saying, oh, give me the first one, give me the second one, give me the third one. And every time it knows to give me the next one over and over and over and over again. So it's technically like just using that yield right here. And that's what this is going on here, is that every time you call it, it's going to yield the next song with number 1 on there. So it's kind of like a return, but like you can come back to it every single time. Okay, that makes sense. Hopefully I'm not getting too complicated there. I see a little handshake. Think of a return basically, but like it remembers what you asked it last. So when you returns the first one, if you call it again, it's going to return the second one and then the third one. Okay. So that's going to basically do our mapping. And then our reducing is going to take the whatever key values. So remember, the reducer is going to take basically a bunch of key and values, and it's just going to sum up the values. So in this case, data house rock, it's going to take that key and it's going to sum up all those values. Note that there's again a yield because you can technically have multiple keys. So maybe it has data house rock and deep dreams versus, before we just saw just giraffe, just koala. It's possible it might have multiple keys in that one reducer. So we're going to do those multiple parts. So that's why we have to have this yield in here in case it calls it more than once. Okay. But in this case, it's going to do all the parts. And that's all we have to define in this case is that mapper and reducer. The shuffle and the split are all going to be handled by the resource management that's built into MrJob. We don't have to really think about that. So when we run this now, I know I'm kind of over, but you guys have no place to go, right? So I'll go ahead and run this right here. So Python is going to run this songcount.py, got their data, and I'm going to run this guy. And you'll see here, it went ahead and counted out. Deep Dreams occurs 1,131, 828 times. It's Data House Rock, and Broken Networks 5 and 10. So basically, it did all this process through the mapping, the whole MapReduce process. Okay, so this is very similar to like what we had with like the animals, right? You're like, okay, like count how many animals there are. So I know we're technically over. Do you guys want me to just go and show you the last example I have down here? Cool. Okay. So before I move on to that last example, any questions on like what's going on here? I think hopefully you guys can picture a little bit from like that diagram, like what's going on. And the main part basically is that we're just defining what defines as a mapper and then what defines as the reducer. Okay. Any questions? Okay, the weirdest thing probably is this yield part, right? Is that this is something that's relatively new. Okay, so, all right, by ignoring that part then, we can go to part 2. So code 2 is we're gonna take Romeo and Juliet, and what we're gonna do is we'll say how many words, how many times each word occurs, okay? So you can see here in Romeo and Juliet, I just, the last 35 lines of this data set, you can see here are some really fun, I'm not big on Shakespeare, but you can kind of see a little bit going through the play here. And then we also note that we also have some end parts here that are not going to be, what's it called, like the actual play, but it's going to still occur in here. So if I actually open up Romeo and Juliet's data, you can see here, for example, the Project Gutenberg. So it's going to include these parts in here. So kind of note that's like, okay, this is going to be a little bit dirty. But once we get into the middle here, you can start seeing, yeah, there we go. So you can kind of see a little bit of the play itself. Okay, so we want to see how many times these words occur. Note that already, like that, it's going to be an issue. Is that, for example, if we split this up by just the spaces, what's going to happen with each of these words? At least even just looking at just this line right here. What's the first word in this line?
Well, it's kind of like it is the nurse, right? But it's abbreviated.
It's abbreviated, so the first word is going to include that dot in there. So note that that might be an issue, but the third word here then will be ours with an E, right? But it's going to include that comma, so that's going to be an issue too. So we're going to have to do some pre-processing in the mapping step, right? We're going to take this word and make sure the key is not going to include these, commas and stuff. For example, this of right here with a comma is going to look different from this of. This is going to be considered 2 different words if we're not careful, right? Does that make sense? Okay. Also note that like capital, like for example, well, for example, versus like well in the middle of a sentence, we're probably just going to lowercase everything that way to make sure well and capital well is the same word, right? Okay. So these are kind of things you can do. It's like, okay, this is a little more complicated than like what we saw before, but it's not too bad where we can't do it. So I'm actually used wordcount.py, and this is where we have our mapper and reducer. So note that our reducers looks pretty small, but our mapper is a little more complicated than last time. So last time we basically just took the, in this case, we took the song and just passed the number 1. But in this case, we're going to have to take, because it's going to read it line by line, it's going to take in that line, and we're going to have to strip out any extra spaces, right? And then we're going to, basically, in this case is my little code. It's not the best code to remove punctuations, but basically it's going to take this and replace anything with a punctuation or identifies with a punctuation and just replace it with an empty space. So that way we get rid of any exclamations. So now we have no extra space, no punctuation. So now that means that if we have something like doctor or nurse with abbreviated, it's just going to be NUR and UR. But that's okay. We're just looking at how often that occurs. And then we're going to take the words. We're going to split it right here. And this is where the yield part is really obvious. So for example, if I put a return right here, and I do for word and words, after the very first word, it's just going to stop the function, right? It's going to not do anything more. But this yield part basically is that every time it calls the mapper, it will continue on with the next part. So it'll kind of keep going over and over and over again. So this is why yield's more useful in this case, because then we can keep calling it forward and it'll just move the for loop forward. Okay. And note that I lowercase it, that way it's consistent. That way we don't have to worry about it's the beginning of the sentence or the end of the sentence. And of course, number one, since there's only one word in there. Okay. And then reducer, you can see reducer, it's just taking the word and then the sum of whatever, how many times that occurs. Okay. Any questions on, especially this mapper part? Any questions on this? Okay. Yeah. So just remember this mapper is basically, it's doing that pre-processing step, basically. It's making that key and that value. In this case, we have to figure out from that single line, what are the different keys? So this is kind of like the, if you remember back with our code where it basically, was it like tiger, lion, and like giraffe or whatever, taking that one line and it has to map it over to lion one, tiger one, you know, giraffe one. Okay. So run this now.
Typically, do you do like the pre-processing in the mapper?
Right, yeah, usually that would be kind of what's going on here, is that we're taking the line and then figuring out how to map that line to some key value that we're going to be used later on in the reducer. Cool. All right, so let's go ahead and run this guy. So we'll run this through, and that's nice too. You can also see how long it's going to take. So I know this is like took 124 milliseconds. So we run this guy, you can see how long it takes. It'll take it like about a second. And you can see here, and it took about 920 milliseconds, so about a second. And note that too, this is kind of fun, is that you can see, for example, all these different words here. You can see pretty and petty and stuff like that, how often they occur. Note that they're kind of out of order, like no alphabetical order that you can kind of like for example, PR, and then it goes, you know, to other parts. And that's because the mappers and reducers might be going in out of order because it's doing it in parallel, right? If you look carefully at some of these words too, you might find that some of these words might not be real words. I can't see, oh, for example, I don't know if that's actually done by itself, but you can start seeing a little bit of like what's going on. Oh, maybe I did a pretty good job. Okay. Sometimes you might find, for example, words that don't actually exist. For example, like the nurse would be, and would be something like NUR versus like, you know, nurse. Okay, cool. Any questions? Pretty good.
Why are the sum of the numbers towards the left?
Yeah, it's just, I think it's the way, by default in this class, there's a way to print it out. I think the printout just a tab. So there might be something like there's an extra space here. So it's just formatting. You could probably change it up if you wanted to, or read in this data into some other format that would be useful to you. Okay, cool. So anyway, that is some code of MapReduce. Again, I try to show you guys without Spark because I'm trying to hope that maybe it's a little bit more easier to understand because you kind of see object-oriented programming. I know the biggest thing is probably this yield part is going to be kind of new, but hopefully that makes sense of like how this is working in the sense of, you know, in the diagram that we saw. Okay. Cool. All right. Well, with that then, I'll go just stop the recording here. All right.